Welcome to this video guide where I'll be covering stacking functionality within the Ultimate Socket system. Stacking is quite a common use case for socket systems, although the requirements from each project can vary. The stacking functionality in this system is designed to fulfill the needs of many of those use cases. For this guide, I've got a simple demo scene set up. The models are third-party assets and are not included in the socket system. A link to the assets is in the video description. I've already configured my placement items, so we can jump right to the stacking functionality. You can check out the other video guides to see how to set up sockets in the Ultimate Socket system. In this guide, I'll explain the different types of stacking behavior you can achieve in your project and how to create your own custom spawn transitions. For this example, I'll be stacking cannonballs into a cannon as seen in the promotional video. I've added a socket to the cannon and a circle sprite will highlight when an item enters the placeable range. I've also turned these cannonball game objects into placeable objects. I've given them different colours so we can tell them apart. So, to allow us to stack multiple items into this socket, we'll head over to the stacking tab and tick the Make Socket Stackable checkbox. We're presented with a few options to configure the stacking behaviour, but with the default settings applied, this socket is technically now stackable. Well, nearly. Before we touch on any of these settings, we need to make the cannonball stackable as well. Let's do this now. So, similar to the socket, the placeable item has a stacking tab. If you enable the stackable checkbox, you'll allow this item to be stacked. It's important to know that if you make a socket stackable, you won't be able to place a non-stackable item in the socket if there are already stackable items in there. However, you can add a non-stackable item to a stackable socket if the socket is empty. Finally, you won't be able to add a stackable item to a stackable socket if there is already a non-stackable item placed in the socket. To sum up, you can't mix stackable and non-stackable items in the same socket. Okay, let's head back to the stackable tab on the socket. Let's take a look at the options we have available to us. There are two options for stack types: clone and instance. When the socket has a clone stack type, the first item in the socket is the original copy. Then, any other items added to the stack will just become clones of the original item. This is great if you need some kind of dispenser where you won't care about the state of an item as it's socketed. Let's see a quick example of this now. I'll add these different colour cannonballs to the socket, starting with the red one. Now, if I start to take the items out of the socket, you'll see each item is a clone of the first red cannonball. This is quite efficient because the socket just stores one game object and then a count of how many clones there should be. On the flip side of that, you have the instant stack type. This type of stack will keep a queue of all the items added to the socket, useful for when you need to preserve the state of the items added to the stack. While we're looking at the instant stack type, you may notice a new option has appeared: the instant stack type. This option controls which type of queue the items are added to. You may have heard of these two terms before, FIFO and FILO. They stand for first in, first out, and first in, last out. If you have the queue set to FILO, then when you add a new item to the stack, it'll be the top item in the queue. Therefore, it'll be the one visible in the socket. If you set the queue to FIFO, it's the opposite. So when you add an item to the stack, it'll be at the bottom of the queue, and you'll have to remove all of the other items in the stack before you reach the item you've just added. Let's take a quick look at the two different stack types in action. The instant stack type is currently set to FILO, first in, last out. So when I add a new item to the stack, the current item is pushed to the back of the queue and I see my new item in the stack. When I take items out of the stack, you can see the previously placed item is spawned and the last item in the stack is the first one I placed. Okay, now the instant stack type is set to FIFO, first in, first out. So when I add new items to the stack, they join the back of the queue and my original item remains displayed in the socket. Then, when I remove this, the next item I placed is spawned. Okay, now we've looked at the instance stack types, let's quickly change the socket back to clone type so we can take a look at the infinite replacement option. The infinite replacement option adds functionality to the clone stack type to keep spawning replacement items even if the stack is empty. Probably not for most use cases, but it's a nice quick option to enable if you do require this functionality. The remaining two options are used for both clone and instance stack types. The max stack size property sets a limit to the number of items you can have in a single stack. The stack replacement delay determines how long to wait before spawning the replacement item. You probably don't want this to be 0, as it's recommended to give the user a second to fully remove the object out of the socket before the replacement spawns and collides with it. Next, we have this option to create some example stacking UI. This is only intended to be an example of how you could create your own UI that displays the size of the stack. However, it does come in handy if you want to quickly prototype something and view the stack count. When you click Add, the example count UI is nested under the socket. We'll take a quick look just to see how you could display the stack count in your project. So, this game object has some UI elements and a single script to display the count. Let's take a look at the script. The core elements of the script are this. It has a reference to the socket. It hooks into the onStackSizeChanged event. When the stack size changes, the updateCountUI function is called to update the text and animate the fill. That's a quick look at the stack count display controller. I thought it would be a good idea to have a practical example to guide users on how they could create their own counters and display the stack count. But hooking into the onStackSizeChanged event should be the main takeaway from this example. Finally, we have the spawn transition options. If you've taken a look at the highlighters or placement criteria tabs, this follows the same format. You have a list of components that you can add displayed here. Then, any spawn transitions you do add are displayed below. Let's add the built-in spawn transition. I should probably explain what spawn transition components are. When an item is removed from a stack, the next item will be spawned to replace it. Spawn transitions allow you to hook into that event and apply behavior to the items when spawned. If we add the scale spawn transition to the socket, then when a replacement item is spawned, the item will start at scale 0 and animate up to its proper size over a set duration. This makes the spawn effect look smooth and less jarring. You can configure the properties of the scale spawn transition if you desire. You may remember that on the stacking tab on the placeable item, there is also the option to add spawn transitions. You can add spawn transitions to either the socket or the placeable item. Spawn transitions added to the socket will be applied to any item spawning in the socket, and transitions added to the placeable item will only be applied to those specific items. If you had a scale up spawn transition on the socket and a spin spawn transition on the placeable item, when that item is spawned, both transitions will play. The system is designed to be extended, so if you want to create your own spawn transition, you can. I'll show you how you can do that now. Let's create a spawn transition that will spin when the object spawns. To do this, we'll create a new script called spin spawn transition. To turn a component into a spawn transition, you must use the iStack spawn transition interface. Make sure to add the necessary namespaces. The stack spawn transition interface only has two functions that you need to implement. The isSpawning function is used to tell the socket system if the item is spawning. It's important to track the state of the transition accurately, otherwise the system may behave strangely if the transition reports that it's still spawning when it's not. I recommend creating a boolean to track the isSpawning state. Then, in the isSpawning function, return that boolean. In the onEnable function, you should set isSpawning to false, just to ensure the state is reset. Finally, there's the spawn function, where the main logic happens. The spawn function is passed a reference to the socket and the placeable item, which allows you to use either of them in your custom transition. For the spin transition, we'll just use the placeable item. Now, as soon as the spawn function is called, we must set isSpawning to true. Next, we'll define a serialized field for a target rotation and give it a default of 360 degrees. Right below that, we'll define another field for the spin duration. Let's give it a default of 1 second. Now, we just need to spin the object. There are many ways you could do this. For this example, I'll use a tween. To avoid this asset having dependencies on third-party tweeners, the Ultimate Socket system ships with its own basic tweener. It's used internally, but you don't have to use it if you have another tweening solution you prefer. For this example, I'll use the built-in tweener to rotate the object over a specified duration. Okay, now I'll implement the tween. We'll tween a float from 0 to the target rotation over 1 second. In the tween update function, we'll do a quick check to make sure the placeable object isn't null. If it has been destroyed, we must set isSpawning to false. Now we'll create a new target rotation using the output value of the tween. Next, we'll update the local rotation of the root transform game object. Finally, another very important step, when the tween has completed, we must set the isSpawning boolean to false to tell the system we've finished our spawn transition. And that's the new spawn transition, so just remember to ensure that the isSpawning boolean is correct at all times. Let's test out the new spawn transition in the editor. Now we're back in the editor, our new spin transition automatically shows in the list. We could add this to either the placeable item or the socket. We'll add it to the socket to save us from having to add it to each placeable item. Okay, let's test out our new transition. Okay, cool. So as I remove the item from the socket, I can see the new spawn effect is spinning the replacement item. That wraps up this guide on stacking functionality. I hope you found this helpful, and if you have any questions or need help, please reach out via the Discord or the support email. Thank you for watching this guide.